Okay, for this mock exercise, we're going to take a look at decision making again. And this time, we're going to focus on the make versus buy decision making. So remember, in decision making, particularly for short term, oftentimes management will be asked to decide on whether to accept special order, which is what we saw in the previous video. And that previous video that we saw was the video on Manly Company. Now, sometimes they're asked to determine whether we should make or buy decision, and that's often the case for companies who make their own products, and perhaps they could utilize the synergistic value economies of scales of other companies who can produce it for less. And that's the question here for Fielder Company. So let's take a look at the question. And by the way, the other two decision making that will often be asked of management in the short term, apart from special order and make versus buy, it would be the constraint resource, is what we saw also in the Manly question, the constraint resource. So which one of the products are you willing to give up? And the fourth one is whether we should close a particular product line or close a particular decision or a division. Okay? So this one is about make versus buy. Now, one of the things that we need to make sure that we're aware of is that when we have a make versus buy decision, we need to make sure that we incorporate the decision with looking at both the advantages and the disadvantage. So clearly there's a financial advantage. So if you make it, this is how much it costs you to make, but if an outside supplier is willing to sell it to you, you need to compare the two different numbers, and obviously quantitatively you would decide which one's cheaper. But you also have to look at the qualitative aspect of the make versus buy. And one of the advantages of the make is you've got a much smoother flow of parts and material. In other words, you'll make it when you need it. You don't have to wait for the supplier to send you the stuff. You can also control the quality of the product that you're making. So let's say one of the items that you currently make is an important material to your finished goods. Okay? So the fact that, again, there could be lots of recall, and that's why a lot of car companies, instead of outsourcing and buying, let's say, parts for their car, they end up making, or they end up buying companies that make those parts because they can better control the quality of those parts. And finally, the profits, you realize the profits internally by making the product yourself. The disadvantage, and the big one here, is the company may fail to take advantage of the supplier who can create economies of scale advantage by pooling the demand from numerous companies. So an example of this would be jeans, production of jeans, jean wear. So there's only probably 3 or 4 manufacturing companies around the world that actually makes jeans, because they've got the economies of scale to actually make those jeans cheaply than, let's say, Levi's would. Because Levi's essentially don't make their own jeans. They may create, they may design it, they may buy the fabric separately, for example. But the ones that make those jeans are actually the same maker, same as, let's say, the Calvin Klein jeans, as an example, or other types of jeans. So this is a good example where they can then determine, or they can then take advantage of those economies of scale. Okay, so let's take a look at the question. It's a short question. It's a good one, though. This one says that Fielder, so let me make this bigger, Fielder is currently purchasing a component for $13, but it's considering making the parts internally. The plant engineer suggested 2 alternatives. The first one would increase fixed costs of $12,000 per month and incur variable costs of $9,000. And the second one is fixed cost of $20,000, but the variable cost is $7,000. So there's really three options. You buy, you make, and you make, but we'll have an option 2A and 2B. Now, first question says, what volume is necessary to make the parts? What volume is necessary to justify making the parts? So let's look at the first question together. So the volume would be, so we've got a couple of options, right? So what they're asking us to do is to find the point of indifference. Okay, so on one hand is the buy, and the buy is 13 times quantity versus the make. I'm going to call this alternative 2A in my question. And the first alternative is 12,000 fixed cost plus 9 variable cost. So solve for Q. And Q equals 3,000 units. Okay, so you bring the 9 over this side, you get 4Q, so 12,000 divided by 4 is 3,000 units. So if more than 3,000 units, which one would be better? It would be the best option. If it's more than 3,000, we would make, right? Why? Because at this point, every unit that we make, the variable cost is cheaper, right? $9 versus 13. But if we produce less than 3,000, the better option is to actually buy. Now, let's look at the second alternative. So this is option 2A. So alternative 2A. And this is alternative 2B. Okay? And that one is, again, the buy versus make. The buy is 13Q. And the make is 20 plus 7Q. Again, solve for Q. Q equals 3,333 units. So again, if greater than 3,333 units, which one's better? The variable cost in the make side is better, right? Therefore, it's make. Okay? That answers part A. At what level, remember, let's go back to the question. It says, at what level of volume is necessary to justify making the part? So that would be 3,000 for alternative 2A and 3,333 for alternative 2B. Let's look at part B of the question. Part B says, over what range of volume is each alternative optimal? So that's the next question. So here, we need to find the point of indifference between alternatives 2A and 2B. So we know that 2A was 12 equals 2B. So it's 12 plus 9Q equals 20 plus 7Q. So again, solve for Q. So I'm going to move 7 on this side. I got 2 Q's. And move 12 on this side. I get 8,000. So Q equals 4,000 units. So solve for Q. Now, if demand is greater than 4,000 units, which one should we choose? Alternative 2A, 2B. Which has the lowest variable cost? 2B. So we're going to go with use alternative 2B. Okay? So now we're going to take a look at combining our answers for A and B. If demand is less than 3,000, it makes sense to buy, right? If demand is greater than 4,000, we know it's alternative 2B. Okay? But what if the demand is in between 3 to 4,000? Which is the better method? Alternative 1. Or 2A. Sorry, 2A. Should be 2A. Okay? Let's look at part C. Part C says, at what level of output 3,500 units, which alternative is most profitable at 3,500 units? So let's do that one, okay? So we know that the alternative is going to be 2A. We know that, right? Because that was what we found in item B. But let's do that one anyway. So if we purchase, it's going to be 13 times 3,500. Alternative 2A, we know it's 12,000 times 9 times 3,500, 43,500. And alternative 2B, we know that's 20,000 times, plus 7 times 3,500, 44,500. So we know that this is the one that will generate the lowest. And we know that, right? We know that because that was our rule. Okay? So that answers that question. Part D says, list 2 qualitative or risk factors that could affect this decision. So we saw that in our technical material. Is the first one is quality, right? The quality of parts and the quality from both insourcing and outsourcing. That's the first thing I would be worried about. Number 2 is delivery time. Okay, so again, we need to control the delivery. We need to control the timing of it. So it's really the timing component of it and the quality. Now, the other aspect of it too as well is we need to look at the maintenance cost of the equipment. So in both alternatives 2A and 2B, and are we able to attract qualified workers and training cost for alternative 2A and 2B. So really what we're dealing with here is the economies of scale. That's the economy of scale component. Okay? Thank you.